Apologies. Hi everybody, my name is Jonathan Ellsworth and this is the codeLaborator project. Bill Collins was acting supervisor. So back in Wednesday last December, I initially proposed to do an application called codeLaborator, and the idea for that was that I would design and develop a competitive coding application where two players compete against one another to complete a task. However, over the Christmas period, I ran into a lot of difficulties with that idea, and so I narrowed the scope down to rather than doing a competitive application, I'll do a collaborative application. And this is how codeLaborator was born. Uh, Obviously, difference being that rather than competing, it's collaborative, and the other difference here being that rather than the players having individual editors, they would have a shared editor that would be designed using socket.io rather than purely relying on HTTP communications. So the methodology I used throughout the project was a mixture of feature-driven and test-driven development. Basically, I designed a list of features and I just picked out a feature, whichever one I wanted to develop at the time, and I would write tests for those features that would test the code. So the architecture I went with was a three-layer architecture that consisted of a presentation, a web, and a persistence layer. Naturally, this mapped very well to the model view controller, so I ended up using the model view controller pattern to assist in the development. And on the right-hand diagram for the model view controller, you see I've just tied the technologies that I used for those essential parts of that pattern. So naturally I use Ginger and Flask blueprints for the views. I use Flask as a controller, and for the persistence there, I use MariaDB for the database, but on the application side, I also use PonyURM, which is an object relational mapper. So basically I have models of the entities on the application side. So here I'm just showing the technologies I use in each layer. The presentation there use typical front-end technologies, HTML, CSS, JavaScript. I use a bit of Bootstrap to just tie all that together. The web layer was written specifically in Python. So these are all Python technologies here, Flask, Ginger, Pony. I'll go into more detail about them later in the presentation. And then the persistence layer consists of a MariaDB database, which is written in MySQL. So this is just a use case that shows my front-end design. So basically, what to take away from here is that a player must log in before they can use the application. Once they log in, they're brought to the hub page and they can go play a game. So moving on. So as I was saying, I used Ginger and Flask blueprints to develop the front end. So the reason I did this was so I could take a modular approach specifically just for developing front end. So that, for example, if I just wanted to develop the hub page, I could have a blueprint for that hub page, which basically had all the operations, i.e. the functions, that were associated with that page. And then I would bind that blueprint to a specific URL. So basically, for example, /hub would be bound to the hub blueprint. On top of that, in terms of the front-end development, I used Ginger templates to help develop the HTML pages with. What that led me to was basically use template inheritance, wherein I could have a base HTML page that just had the basic layout of the website, and then the rest of the web pages, say like the hub, the game page, the login page, etc., could all inherit that base template and stick whatever values they needed into that base template and whatnot. Ginger also allowed me to substitute data in the form of Python if I wanted into those templates, and then there was some error handling done in the front end using Flask. So this is just some of the front end development in which I was talking about. So on the left, I have a blueprint for the collaborator page. So this basically has all the details needed for that blueprint to function correctly, specifically the folder that blueprint is held in, and then any assets and whatnot that that blueprint can use. On the right, this is an example of Ginger's template inheritance, where we're basically saying that this page is inheriting from the base .html page. Then we're inserting the word collaborator into the title of that page. So moving on. So this is my API design. So basically what to take away from this is that there's a RESTful API in the web layer that handles all the HTTP communications coming in and out. So as you can see here, the login can, someone can request the login page and it will be sent back to them. So basically I use Flask to handle all that, which I'll talk about now. So the Flask API, naturally it's RESTful. It deals with HTTP requests, and basically this is where the blueprints are bound to the URLs in the application itself. So that's just an important thing to note here. So I'd also, before moving on, I'd like to talk about that the app itself can use things called request context and application context. So basically what this allows me to do, for example, a request context, allows me to I can set operations that can happen before or after a specific request occurs. For example, in the application, if someone were to request the game page where I've not logged in, I can check to see if they're logged in before, or if someone's, that person's logged in before I send that page. If they're logged in, fine, I'll send the page to them. If not, I won't. Similar application context, you can check the state of the application before you do something. So this kind of leads a little bit more into this, Socket.io side, where it's like, okay, do we have enough users here to start this game before, we try to launch this game? So this is just some code to show the development side of that. So on the left, as you can see, it's the actual tying of the blueprints to URLs. So for example, if you look at the very top line, we're saying import the login blueprint, and then if you look at this top line, the second block on the left, we're assigning the /login URL to that blueprint. On the right, I think this is just some code showing the routes that are tied to that blueprint. So basically, it's a blueprint for the hub page, and as you can see, there's an operation there, hub, that just returns the hub.html page. So this is my backend design. So it's a typical relational database that has entities for the player stats, games played, tasks. So it's an important thing to note here is that all these entities have identical models in the web layer to represent them. The reason we did this was to increase the efficiency of querying the database. But I'll talk about a bit more about that in a moment. I'll actually talk about it here. So basically, we have a relational database that uses Pony, as I was saying, to have models in the web layer that tie directly to the entities in the database. So basically, if I go back for a second, the player entity in the database has a player model in the web layer. So the reason for doing this was to make queries more efficient, and so I could write the queries in Python as well. So basically, the reason this is more efficient, if someone does a query, say they're just asking for a player, like someone signing in, so I need to get a player, and check their user ID, whatnot. The reason this is more efficient, if that query was done again, I wouldn't have to go to the database. It would already be stored in the models in the web layer. And it was also just, as I was saying, it was handier writing queries in Python than writing them in SQL. So this is just some of the backend development. This is what I was kind of talking about there in terms of, on the left, I have the entity for the player written in SQL, and on the right, this is the model for that entity or sorry, this is actually a model for the task entity, and it's written in Python. So I want to talk about the shared editor for a moment. This is basically the design of how the communications work for when multiple people are playing the game. So as you can see here, on the left we have the players, with 3 players, A, B, and C. So when the game starts, let's say the players just ask the right function to get the sum of 2 numbers. And basically player A has written in int sum with 2 brackets. So that gets sent to the server, and it gets emitted back to players B and C. So now everybody has the same thing in their editors. So now player C has written in what's in the purple, return AB, that's wrapped in curly brackets, and that's sent to the server, and then that's sent back to player A and B. So now, naturally, they can type in, well, anybody can type in at the same time. So B is put inside the parentheses int A, comma, int B, and sent that to the server, and it gets sent back to the players A and C. And then when someone hits submit, that gets sent to the server, and everyone's returned to the hub page. So moving on. So this is basically, the shared editor used Flask socket IO, which is a subsection of Flask. And this is where a lot of the difficulty in development was, because it's not it's a newish technology for Flask, and there's not a lot of documentation on it, so it took me quite a while to develop that functionality, but I got there. But importantly, it allowed me to control the packet rate as well, which by having, I basically started using a low packet rate to increase the efficiency of the application. And also I just noted here that I used a thing called the ACE editor. This is basically an editor I imported into the application, and it allowed me to add things like highlighting specifically for C and whatever language I wanted, and some other bits and pieces. Basically I had an editor that I could interact with using code. So here's just some code showing how this all works. So if you look on the left here, this is the front end. So this is JavaScript on the left. So basically, if you look at the bottom of this where it says editor.on, this is when someone types into the editor, input into the editor. So then collab update is emitted to the server. So now if you look at the right, the very top line, this is Python naturally, is waiting for a message come in that with the header collab update. When this is sent in, it takes the data and broadcasts it to the other users, excluding the user that sent it. And then if we go back to the left code, when socket.on update editor, update editor is being emitted from the server, when that comes in, we update the editor with the code that has been sent. So this is just some of the testing I did. I think I mentioned earlier that I had some difficulty using typical test-driven development for the socket.io part of it, because naturally with socket.io, all that code, so if we go back a little bit, so that function on the right, for example, it's expecting a request. So I wasn't able to wrap it in a test. I even tried wrapping in a test that would mimic a request, and it wouldn't work. So I had to come up with a few different coding methods. So this is basis path testing, and the idea here, as you see on the graph on the left, is that I was basically ensuring that when a user sent a message, that the other users would receive it. I wasn't too worried about, for this testing, if it came through in the correct manner, as in, if someone typed an int, that it was int that came through on their side. I was just testing what, because I did some more testing for checking the data, which I'll talk about in a moment. So as you can see with the tests here, the scenarios, pardon me, the scenarios here, they all came back successful, so I didn't have to worry about that. So move on to the next. So yeah, data flow testing, which is kind of what I was just mentioning before, where this is what I'm worried about, the form the data comes in. So cases 1, 2, and 4 were fine, but case 3 was where I actually discovered should I call it a erroneous case where if I was just held down, the backspace wouldn't delete, the whole string wouldn't delete. There'd still be parts of it left. And I noticed that case 4 came back successful for those who are saying if I typed really fast, but I expect there's probably errors if I typed really fast as well. And basically, what I discovered, it was actually the way the position was being updated in the editor, and I managed to fix that thankfully, so it doesn't happen anymore. So just talk about some of the challenges I faced. Naturally, having to learn Flask, which I'd never used before, was a challenge in and of itself. Some parts weren't too bad, like some parts had good documentation, but other parts like the socket IO for Flask had very little documentation since it's practically brand new. So I had to, I suppose in reality it was a little bit of brute force trial and error, and just drawing on bits and pieces from examples online. But I got through it with that at the end. Time management, naturally, I had trouble with that. And I suppose I had a little bit of trouble with Pony, just never used object relational mapping before, but it kind of came to me after a while, just playing around with it. So future work for this would include porting it to the cloud. I actually have a bunch of Docker stuff written for this, but I just never got the time to test it properly and port it, just use it to port stuff to the cloud, unfortunately. But I reckon that would be a pretty quick thing to do just once that stuff is tested. And then matchmaking would have to be developed from scratch. I just ran out of time on that one, unfortunately. I wanted a matchmaking that didn't rely on just giving the players a list of lobbies. Like basically, I wanted to be almost like a computer game where it just automatically matches you. You don't have to see any of that stuff. It just finds a player for you, and then you're all in the game together. And yeah, that's what I'd hope for in the future for that. So thanks very much, and this is the end of the presentation, and thank you for listening.